Hi everybody. So we're going to do problem 66 and then problem 46 out of the book in section 5.1. And 66 reads, find the dimensions of the rectangular corral producing the greatest enclosed area given 200 feet of fencing. So my drawing begins. If I've got a rectangle, and that means, and I have 200 feet of fencing, 100 feet of fencing would be used for these two sides, and 100 feet of fencing would be used for these two sides. So if I label this piece X, this piece has to be 100 minus X, and 100 minus X and X, because it's a rectangle. Now, the area formula for rectangle is length times width, and this is what we're trying to maximize, so that's why we're using that formula. Now the length is 100 minus X, and the width is X, according to my drawing. I multiply these and I get 100x minus x squared. Now notice that's a negative on the x squared term, so this thing opens down. So the vertex is where the maximum is going to occur. You know, it's an upside down parabola. Okay, now the maximum will occur at the vertex, like I said, and it occurs at the x-coordinate of the vertex, which is negative b over 2a. Well, the b is attached to the plane x, so I do negative 100 over 2 times the a, which is negative 1, and I get 50. So when the x is equal to 50, you have the maximum area of 2,500 square feet. Okay. Now number 46 is asking us to actually figure out the standard form of the equation, and they give you a table. Fortunately, they didn't give us any chairs. So what we do is I'm looking to figure out where the vertex begins, and this time they gave us where it starts because of the equidistant relationship. So I went over one there, and I went up to 2 there. I went over 1 there, and I went up to 2 there. I went over 2, I went over 2, and so I have this matching going on, and that's why I know that this is the vertex. The other graphs don't necessarily have it that easy, so you have to play around to figure out where that vertex lands. So my vertex is 0, 1. That means my axis of symmetry is x equals 0. Now, it's easiest if I know my vertex, because I can plug into the vertex form, but I don't know my a, so leave that a there. So y is equal to a times x minus 0 squared plus 1, and I multiply out what I know, and I end up with y is equal to ax squared plus 1. To be able to figure out what the a is, I need to pick a point, and I chose the ordered pair 1, 2. So I put the 1 in place of the x, 1 squared is 1. I have the 2 out there, and I found out that my a is 1. So my vertex form can get converted to the standard form by multiplying it out, and you get y is equal to x squared plus 1. So get it into vertex form, figure out what your a is, and then multiply it out. Now, because I have the 0 there, that immediately just drops off, and I get my x squared, and the a is 1, so this one really isn't a very good indication. So in the previous video, I showed you how to multiply out the vertex form to get to the standard form, and that's what you'll do on those problems. All right, have a good one.